Hey folks, my name is Fernando and I'd like to share a couple tips with you today about these farmhouse tables that everybody's building. And there's tons of plans online, everybody's building them nowadays, building them out of Home Depot construction grade lumber. And most of the plans out there are a very poor design, and I'd like to hopefully shed a little bit of light on it. I learned the hard way, and I would like to maybe help some other person out there that's building one or buying one. They're being built wrong and they're coming apart because of it, and I'd like to show you the first one I built. Most of the plans out there have the breadboard ends, and the breadboard ends are being held by pocket screws. And pocket screws are great in some situations, but they do not work in this situation. And I'm gonna show you one of the first tables that I built. I started woodworking. That was one of my first projects, was doing one of those farm tables, and I don't remember where I found the plans online. Where the whole thing was screwed together with pocket holes. So I went out and bought a pocket hole jig, a screwdriver, and a circular saw, and I got to work and I built the table. Well, it cracked, and let me show you exactly where. Let's take a look at that table. Before I show you the table and what happened to it, there's one thing I want to talk about, and this is what I did not know when I first started doing this. I had no idea about wood movement. Wood is a very dynamic thing, and it changes in dimension based on the amount of humidity in the air. And I didn't learn that till it was too late. But basically, wood is like a bunch of straws in the direction of the grain, and they will absorb humidity. They will absorb water in the air. And as they absorb water, this board will expand this way. It'll get more wide. And that is the problem with the design, that some of the boards are laid out with a grain like this, and then the breadboard ends are laid out with a grain like this. These boards want to expand that way, and these boards will not do that. See, this board will only expand across the grain. It won't expand lengthwise. And the two boards get bound up. So one board is holding the other boards from expanding. And at some point, something's going to give. That the water is a hydraulic fluid. It cannot be compressed, and it has incredible amounts of strength. So if I can show you here this table that I built. When I first built this table, and I attached the breadboard ends that are screwed on here improperly. When I finished, I actually, and this is not, now I use this table kind of like a workbench, and I paint stuff on it and everything because it's garbage, but it'll hold things. When I finished, I actually cut this I ran a circular saw down here with a guide that made everything perfectly even. Now I'm going to show you an up close look at what happened to it. So here you see the edge of the table where the grain's running lengthwise, and here's the breadboard end. These boards, especially the construction grade lumber, it comes with a ton of water in it. They don't really dry them out the way they do the hardwoods. But if you look here, and it's a little tough to see because I don't have the best camera, but if you look here, these boards have actually shrunk, and this has maintained its width. This is still the same width that I originally cut it to, but this right here has actually gone inwards because these boards have dried out and they have shrunk. And when the moisture in the air will come up, these will once again grow and they'll come back out. You can see how this board here has shrunk. What did that cause is, if you look down the center of it, let me zoom out a little bit, the table has cracked. You can see where it finally gave in. It cracked down the middle, and it was nice and level, and you can't see because of all the paint that I have on it and everything, but this was not nice and level, and right now there's kind of a bulge right there because as the wood contracted, it had nowhere to go. It pushed up and it cracked because this board wasn't allowing for the movement of the wood. So now you've seen what happened to my table that I built incorrectly, where I screwed the breadboard ends into the center section of the table. And it's even embarrassing to show that to the world, but some of your best learning lessons are from your mistakes. And since then, I've gone and watched other videos of people out there that actually know what they're doing, like the Wood Whisperer and Jay Bates, and I've seen how they put breadboard ends on tables, and now it's all made sense to me. And so I'd like to share how I do it now the correct way. I have fancier tools now than when I first started, but it gives some folks some ideas that are trying to build these things and hopefully steer them away from doing it the wrong way like I did. So I'm building a farmhouse table here out of regular construction grade Home Depot 2x8s, because this is not my preferred material, but this is what most of you people are using. So what we're going to do is we're going to attach the breadboard ends using a mortise and tenon joint, and I'm going to show you two different ways to do it. There's a very fast but expensive way to do it that requires special equipment. And then I'm going to show you an alternative method for those that can't really afford to buy the expensive equipment. Now I've already assembled the center section here, and I've taken a circular saw and I've cut off the end to make a nice straight edge here. One thing I want to mention about this, to save yourself a lot of frustration, is take the time with your circular saw to set that blade exactly at 90 degrees and make sure that you have a perfect 90 here where your blade cut, or you're going to suffer a lot of frustrations trying to get this to sit level. Also on the breadboard ends, same thing. If you do it on a table saw, just make sure that blade is perfectly 90 so that these two will mate up nice and flat. I've run mine over a joiner, so I know mine are flat, and I know it'll all come together nice and flat. But the first couple times I did this, I didn't have perfect 90s, and I suffered a lot trying to get everything to fit nice. Next thing is you want to choose the orientation that you want to set your breadboard in here, and I've flipped this around 10 different ways, and I've come up with, I think this is the orientation that looks the best for the wood that I have here. Now you want to make sure that this doesn't move anymore, and we're going to take a square and we're going to draw some lines from the breadboard to the main table. Now I'm going to put two fairly close together here right at the center, and then we'll move out from there, and I'm going to put in six lines total, and that's where our mortise and tenons will end up. So the method I'm going to use here to do my mortises today is the Festool Domino. I know this is an expensive machine. Most people, that if you're just going to build one of these tables, it's not worth buying. If you're going to do a lot of this kind of work, then it's a game changer. This thing is there is no more efficient way of doing mortise and tenon joints. But I'm going to cut my mortises with this machine, but I will also show you an alternative method if you can't afford this machine, or if it's just not. Now that we have all our mortise holes cut, we can go ahead and on the table end we can install all the tenons, the dominoes. We can glue all of these in on this side. We just can't glue them on the other side. Glue. Glue on the domino side. And I'm going to go ahead and finish these up off camera. Alright, now we're going to cut the mortises into the breadboard end. And we're going to do it slightly bit different than we did the table side. The two center mortises are going to be fixed. They're going to be glued together, and we're going to make those mortises the exact same size as the dominoes, as our tenons. The outer 4 mortises are going to be wider, so that those tenons can float in there and allow for that wood movement. And luckily, the Festool gives us the option of cutting regular size domino mortises, slightly wider, and then really wide. So for the middle 2, we're going to use the tight setting, and then for the outer 4, we're going to use the very wide setting. Let's go ahead and cut those right now. Alright, let's take a look at what we have here. Our center mortises, if you look at the domino, fits in there precisely, no movement back and forth. But if you look at these outer ones, they got plenty of side-to-side movement. And that's the magic that allows the center of the table to expand and contract. Let's show you how we put it together. You're probably going to say, I can't spend the money on that Festool domino. It's too expensive. I'm not a professional woodworker. I can't justify it. So I'm going to show you how I used to do these before I had that piece of equipment. Really all I did was I used a router. I love this thing. Old DeWalt plunge router with an edge guide. And then I made a simple little jig, and these are my stop and end points for my mortises, so I can make all my mortises the exact same size. And then I used to make my own dominoes. Obviously this is too long, but this was like scraps I had laying around, and I would cut them to I had a set length, set width that I had for these. I would cut them on the table saw, and then on the router table, actually in the beginning I didn't have a router table. I just used a block plane, and I rounded over the edges, and then I would use a 3/8 inch bit in the router, and I'm not going to cut one, but I'll show you how I would set it up. Basically, I just take my little start and stop point, and it just fits right over there, and I have a line right there where the center of the mortise was going to be, and just go ahead and clamp it onto my workpiece. And once that's clamped on, then you just take your router, you set it in between those, and you just plunge route and just go, go in a little bit, make 3 passes at it, cut, go down, cut again, go down, cut again, and you'll have a perfect mortise that you originally sized to the tenons, the loose tenons that you make. And it's kind of a poor man's Festool domino machine. Worked great. Your other option, if you can't even afford that, is to take a hammer and chisel and make mortises the old school way. I'm far too lazy to do that, and it's hard to talent that I don't really have. But that's how I used to do it before the Festool. So you can buy a $200 router, and actually the first router I ever used, I bought it at a pawn shop for $25 and did the same thing. This one's a little nicer, but you can get the job done with a lot cheaper tools. These are just different options you can use. Alright, let's go ahead and install our breadboard end. Slip it on here. Just wanted to point out, if you look at the middle ones, those we're going to glue. Those are going to be tight because there's really, in this little 4-inch section here, there's not very much wood movement. As we move outwards, the further out, the wider this table is, the extremities are going to have the most movement. And that's why you see in here, as this board moves in and out with moisture, we've left some slop in here so that it can freely move back and forth without causing any cracking or anything. The breadboard end is here to prevent everything from warping, but now what we're going to do is we're going to drill some holes and we're going to run to some pins, and I'll show you how we do that in just a minute. Alright, now that we have the breadboard end on here, I needed to draw it tight, but I don't have any clamps that are long enough that'll span this tabletop. So what I did was I just used a couple of ratchet straps here to pull it tight. It's kind of ghetto, but it does the job. Also, if you do that, you want to put some, I put some cardboard here to protect the edge of it so it doesn't get crushed. When we finally attach this piece, what we're going to do is the center two are going to get glued. They're fixed. They don't move. And then the outer ones, we're going to pin them. So what I did was I cut up some 1/4-inch dowel, and I will be installing these into holes I've drilled. I haven't drilled yet. I mean, I've marked a 1/2 inch from the edge. There's 4 of them here that I'm going to drill, and we're going to use these. But after we drill them, we're going to have to pull this breadboard out, and in the tenons that are coming out of here, we have to elongate the holes so that gives the board room to move. Well, I'll show you that here in a minute. Let's just drill these holes right now. Now before we drill those holes, I've taken this drill bit that I'm going to use, and it's a 1/16 undersize, so those dowels will fit in there nice and tight. And if you notice, I don't want the drill bit to go all the way through. I just want it to go through the top part. I want it to go all the way through the tenon, but I don't want it to come out the bottom of this board. So I've put a piece of tape on there as a guide so I don't penetrate all the way through this board when I drill these holes. Make sure when you drill these holes that you hold the drill nice and perpendicular to your surface. So there's our hole in our tenon, but if we drive a pin through that, that still leaves us in the same position. It doesn't allow for the movement of the board. So what we want to do is we want to take this hole and elongate it so this board can move. And I just do it with just a drill bit, the same drill bit, and you want to make sure that you tilt your drill bit this direction to elongate the hole, but you definitely don't want to go this direction. You don't want to make the hole loose. You want this hole to be in the same, parallel line with here, because you need that pin to pull it close to keep that breadboard attached tight here. There, now we turned our hole into more of a slot. That way when this pin goes through here, this board is actually able to move back and forth about an 1/8 inch or so. Same thing with these other ones. I'm going to go ahead and I'm going to elongate all of them. Okay, now for our final installation of the breadboard ends, we're going to go ahead and put some glue in here for the middle two tenons. Glue on the tenon. All right. I'll go ahead and slide this in. Alright, the center ones are getting glued, and then the outer ones we're going to drive our pins into, our dowels I mean. And we're only going to glue the dowel on the upper, third of it, because we only want the glue to hold the dowel to this board. We don't want the glue to actually glue onto the tenon. We want the tenon to be able to move freely around the pin. I'm going to put the straps back on to hold this tight, then I'll put the pins in. Okay, got it all tight with the straps again, and let's go ahead and knock some of these dowels in. A little glue here on the edge. I should chamfer these. Once those dry, we'll cut them off, sand it down. It'll be a nice strong connection. Well folks, that really is all there is to it. It's really not a hard process to do. I'm not a professional woodworker. I do this as a hobby. I do it for fun. This is not my full-time job. I hope that I have helped somebody in building a table that doesn't crack or warp or give you any kind of problems. Another thing to consider is when you attach this tabletop to your base frame, there's different methods of building the base. You also need a floating system for the attachment of the top to the base, because you don't want to bind up the top. You have to use some sort of slider type mechanisms, or they have the little swivel things. Anything you got to do to make sure that this table can expand and contract even on top of the base. And lastly, this is my very first YouTube video, so I apologize for my poor editing and poor filming. I still have a lot to learn in that arena. Maybe I'll do some more videos here in the future. I got a couple other projects I wouldn't mind sharing with you guys. You guys have a great day. I hope to see you again.